5.7 notes. We are going to finish up this problem, and we have one more problem. Okay, as you're getting situated, I'll re-explain where we were at in this problem. Finding relative extrema, we know how to do that, but now the function involved some inverse for both sine and tangent. So, as a review, how we find relative extremas, we start by finding the critical points, which we look for horizontal tangents when the derivative is equal to 0, and any points where the derivative is undefined. Okay, so we kind of talked about the restricted domain for inverse trig function for sine, and we graphed both of these as well. So the blue curve is the original, and then the red curve was the derivative. So we kind of walked through like how we could do that. And so then that also helped us like fill out the sine chart. So we could see from here to my first critical point, my derivative was positive, which we know that means our function's increasing, which we can see. We have them both here. And then here you see that horizontal tangent when the derivative is 0. And then my derivative was negative because my graph was decreasing, yada, 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 yada. Okay, etc. So that's how we filled out the sine chart. Where is positive, where is negative. And then the only thing we really didn't finish was actually locating the relative extrema. So those are like our local maxes and mins. So here are my results from the derivative, which tells me on my original graph, I always kind of like to put f above this and draw myself a little picture that it was increasing from here to here, decreasing, and then switches back to increasing. So it looks like I have one relative max and one relative min. And if we flip back to the blue curve on our grapher, we can see that there is our max, there is our min. So that matches with what we found by using calculus techniques. So all we really had left to do was like state relative max was here at negative 0.68125, and then I actually plugged that value into the original function, and I got this number, 0.4465. If they ask me for a point, or maybe they just ask me for the x value. Because f prime changes from positive to negative, that's why there's a max there. And then a relative min at 0.68125. When I plug that in, I got that same value at negative 0.4465, yada, 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 dot, 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 because f prime changes from negative to positive. That's technically using what we call the first derivatives test, where we look at the sign on our first derivative to recover information about our original function. So our original function, we would say the original function changes from increasing to decreasing, but we want to use our findings from the first derivative, so it changes from positive to negative or negative to positive to locate the relative extrema. Okay, do you guys remember that? How to do those?
Maybe.
It's been a while since we've done one of those. And you know I had to throw in a tangent line one mixed in with imp diff, two of my favorite things.
You really love this problem.
This is the best one. I saved it for Friday.
I need to find you some hobbies.
I have a lot of hobbies.
This is your favorite thing?
I saved this one for Friday. I was like purposely kind of going kind of slow yesterday. I was like, I want to save this problem to do on the most fun day of the week, which is Friday. Because I get to wear jeans and I get to put my hair up and everything's good. You know?
Don't you have your hair up every day?
I
Why
wear
can't
my.
you wear jeans other days?
I don't really
It's
know
like-
what the
it's
dress
like
code is
casual
here,
stuff.
but in Mugwanago we can only wear jeans
Oh,
on
hey,
Fridays.
that's what I was told by the student teacher in Miss Claus. That's her name now.
Yeah.
And then I asked Miss Bailey, she's like, "Oh, I didn't know that."
I don't know if that's what it is here.
'Cause,
That's
like,
just
at
what
the
it used
bank,
to be.
I have to pay $5 for wear jeans on Friday,
That doesn't seem right.
and it goes to
Oh,
charity.
Yeah, okay, that's.
So do you pay the $5?
No, because they don't make me a student, so
Oh,
I'm only wearing it for an hour after school. So like, if you really gonna make me pay $5,
yeah.
And I also didn't know that I had to pay $5, so I just didn't get it.
I also don't want to get mistaken for a student. That happens to me sometimes, so I have to dress a little professionally.
How about this? Plus
Just the other day, I went to UW-Platteville I had to get a COVID test, and they were like, "Okay, do you live on campus or do you live off campus?" I was like, "Oh, I'm a community member, not a student." It's like, "Oh my gosh, you live so young." I was like, "I've been out of college for 6 years, but thank you."
Honesty plus 100.
Okay, so the fun problem. Let's do it. Use ImpDiff to find an equation of the tangent line to the graph of this equation at the point -π/4, 1. Okay, so just like always when I do these problems, I need to know two things. I need to know the slope of the tangent line, and I need to know the point. And the point's already given to me, which is nice. Sometimes just the x value is given to me, and I would have to like plug π/4 into my equation to find the y value, but in this case, both of them are given to me. Nice. So to find the slope of the tangent line, we know we just need to find the derivative and then plug in the point. All right, so to find the derivative in this case, I have to use ImpDiff because this is not explicitly solved for y. Now, I don't know about you guys, but I would not want to try to solve that equation for y, especially because this y is like stuck within the argument of the inverse tangent. Here we go, tangent. Okay, here we go, ImpDiff. First term, just be 2x. Here I have to use product rule. So first, factor x times the derivative of the inverse tangent of y. Okay, inverse tangent is 1/1 plus x squared. Now careful because I have a y here. So y squared. Chain rule. dy dx. Good. Yep, dy dx. Ready to go with that? Plus second factor. I'm gonna run into my point here. Move this guy over. Times the derivative of my first factor, derivative of x is 1, equals, I have a y on this side, so the derivative of y is dy dx, minus 1 would just be 0. Okay, so I gotta do a little bit of cleaning up here. I wanna solve this for dy dx. So what I'm gonna do is move anything that doesn't contain a dy dx to the right-hand side and everything that does to the left-hand side, and then I'm gonna factor it out, just like always. So I did, right here, I did actually like multiply these together. So that would just become x over 1 plus y squared. But I kept that dy dx out here because I'm going to factor it out in a second. Okay, I'm going to move over this dy dx. So minus dy dx equals, and then I'm going to move over this inverse tangent. Oh my gosh, what a great problem. And move this over, minus 2x. Okay, beautiful. Let's factor out the dy dx. Almost done. I'm just going to divide both sides by this. Oh, don't forget when you factor that out to leave behind like that, minus 1. Okay. Now the nice thing about finding the derivative at a point with ImpDiff is we don't have to do a lot of algebra simplifying because we can just plug in our point here. So here's my derivative. It looks pretty complicated. I have a complex fraction. But that's okay. I get to plug in the point, -π/4, 1. And I kind of just like to notate it like that. You don't have to do that. But I'm going to do it right below here. Okay, so I have the opposite of the inverse tangent of y, which is 1, minus 2 times x, which is negative pi over 4, all over x, negative pi over 4, over 1 plus y squared. Y is 1 minus 1. Oh boy, let's test your trig skills. Okay. When we're finding inverse tangent, remember you're going backwards from like taking the tangent of something. Normally, I say find the tangent of an angle, and you give me out the value of that angle. Inverse flip-flops the inputs and outputs. So now I give you the value, and you have to tell me which angle. So for inverse tangent, I always kind of tell my pre-calc students, your answer has to be in one of these two quadrants. That's just how the inverse is defined. Remember we talked about all this when we did the graphs, because was it in this section? Oh yeah, here it is. Like here for inverse tangent, we talked about how we just restrict the outputs to be in between negative pi over 2 and pi over 2 so that it passes vertical line test and it's considered a function. Okay. So does anybody know what the inverse tangent of 1 is? Yes.
Is it pi over 4?
It is pi over 4. Good. So you're thinking, what angle gives me a tangent value of 1? It's pi over 4. And then I have this negative here, so it's going to be negative pi over 4. Good job, Wilson. And then here I would have plus, and 2 times pi over 4 would be pi over 2. All right. Right here I have negative pi over 4 that's being divided by 2, so that's negative pi over 8 minus 1. Okay, so it looks like my slope or my derivative is going to be in terms of pi here. All right. Everybody good so far? Yes.
The negative 1 isn't in the fraction, is it?
No. Does it look like it is?
Yeah, it's in the denominator right now.
Is that better? Oh, you mean this one?
Yeah, there's a minus 1 outside of the equation.
The minus 1 is in the denominator.
Okay, it just looks at the equation on the...
That's over something, Dalton.
This
Pi,
one?
negative pi by 8. Or pi over 8.
This, see how I have a complex fraction here.
Okay,
Yeah.
Okay.
So now I was just kind of simplifying this. So negative pi over 4, and then 1 plus 1 is over 2. So that's how I got that.
Okay.
And then I have that minus 1. Okay. So negative 1/4 plus 1/2 is 1/4. Negative 1/8 minus 8/8. I would do negative pi over 8 over 8. Okay, we're almost done. Times by reciprocal. I can simplify these. Here is your slope. 2 pi over negative pi minus 8. That's nasty. That's the derivative at pi over negative pi over 4. There's my slope of the tangent line. Okay. So now we have our point, and we have our slope of the tangent line. So we're definitely going to leave this in point slope form. We're going to go y minus y1, which is 1, equals the slope, negative pi minus 8 in the denominator, 2 pi, times x minus negative pi over 4 would be plus pi over 4. Oh my gosh. Do you guys love that?
It's my favorite.
What?
It's my favorite.
It was your favorite? No.
I wish I could lie as good as Mark.
Oh, come on. Okay, my friends. There you have derivatives of inverse trig functions. Now we're gonna go the other way. I will say, and I know I repeat myself, but it's just because it's important. These are fair game to be tested on the AP exam, but the only two you have to know are inverse sine and inverse tangent. The integrals, which we're gonna do in 5-8, are rarely tested on the AP exam. Rarely tested.
When's the last time they were tested?
I don't know. That's just what your textbook said. And like I said, this next lesson we didn't do a while ago, so which makes me think it's not very commonly tested, but no.
Okay.
No.
Kevin.
Plus, I picked some fun warm-up problems for this next lesson, so I really want you guys to do that.
But you can be so prepared for Monday.
Oh, don't you worry about me.
We're trying to make sure you're not stressed out.
Thank you. I appreciate you. Your concern about my
We're going right into
mental
Monday.
health.
We want to make sure that you're not like.
This will take us. This will probably do. We'll finish it one day probably. So I don't have to prep anything for Monday because it's probably gonna do this. We're not gonna finish this right now.
All right.
Okay.
You got a problem. We're gonna finish this.
So. Yep, there you have it. Derivatives. Now the last lesson, and because these two lessons are kind of a lot of like formulas, if you will, for like the rules for derivatives and integrals. I'm gonna do this one as like a take-home quiz. For 5, 7, and 5, 8, and then obviously we have our chapter 5 test, but we'll cross that bridge when we get there. Okay, here are the fun warm-up problems. So I stole these. These are 2 problems off an old AP exam. So you can see, obviously, we got arcsine and arctangent. So now that you know those rules for derivatives, why don't you guys try these couple problems?
I forgot ours.
Here,
That's not a good start.
you want to look back at my notes?
Is it the root 1 over?
It's the 1, and then the denominator is the square root of 1 minus x squared.
Look, you already have these memorized.
So start.
It doesn't mean they're fun.
How'd you do that?
I also looked at the notes. I went back and looked at the notes. I almost looked like I memorized them.
Should I make you guys some Quizlet flashcards for these? Okay, I will.
I think we should have the door entry thing.
Hmm?
The door entry.
Oh, you like that?
That's my water bottle right here.
Oh, is that yours on
Yeah.
the blue? Couple days. I was wondering whose it was. Ooh. I guess I could just do one lesson for a day. Actually, it was